Hello and welcome back. This video is the second video, which is a continued discussion of periodic trends. I want to remind you to please watch this video carefully, take notes, and learn the material about trends and why they occur. The previous video detailed information about atomic size, and we have had an opportunity in class to go over that with some practice problems, and it detailed information about ionization energy. So today's video is a focus on cations, anions, and electronegativity value. Hopefully you're organized. If not, please pause the video, get out your notebook, your writing utensil, and your periodic table. Thank you. So our first trend that we're talking about today is the trend for cations. I'd like to remind you that in class I spent a little bit of time talking about how a cation is an atom that has lost one or more electrons. In the process of losing one or more electrons, where the electrons and protons used to be equal, we've now removed some electrons, and therefore we have excess or more protons, and that is why it has a positive charge. We also have mentioned how, because of a low ionization energy, metals tend to be the atoms that lose electrons. This image is from before. This is aluminum when it is 0, 13 protons and 13 electrons. This is the aluminum that is now aluminum 1 plus. It still has the same atomic number, but it only has 12 electrons. This aluminum is aluminum 2 plus. It still has 13 protons, but it only has 11 electrons. And finally, this is when it reaches a level of stability, and this is aluminum 3 plus, where there's 13 protons and 10 electrons. And you can see from that that we have an excess of positive 3. Every time an electron is lost, and the cation is going to be smaller. See how this shows you that in the picture there? It goes from pretty large to smaller to smaller to the smallest. So because we're losing electrons, and the number of protons is pulling those electrons in more, the size is going to get smaller going across. In this case, one valence electron is meaning one electron lost. 2 valence electrons means 2 electrons lost. We're going to stay away from the transition metals here, other than to say that they're going to lose electrons. This is 3 valence electrons, and so of course it's a 3 plus, and sometimes, especially tin and lead, we will have a situation where the 4 valence electrons are far enough out on the 5th or the 6th energy level that they're all 4 lost, and it becomes 4 plus. That is our trend in terms of charge. When we start thinking about the size of cations, we're going to break it into that where we look from left. This is the group trend. We're going to go from top to bottom within the group. Remember, any group trend is most likely due to shielding, and shielding means more energy levels, and therefore more space is occupied. The image below is really quite complex. You are welcome to look at it carefully. I would suggest you start here and notice that everything in this first alkaline metal group has become 1 plus, and everything in this second group vertically has become 2 plus. What we're focusing on right now is looking at the top to the bottom. You will notice that the trend is still moving down through the group. The size is increasing. There are actually a lower number of energy levels for the cations because this used to have lithium so lithium used to be 1s2, 2s1, and by losing that one electron, it now only has one energy level. So it's going to be smaller, but compared to everything else below it, they will get larger. Sodium is larger, potassium is larger, rubidium is larger, cesium is even larger, because they still have one increase in energy level than previously. The reason for the trend from top to bottom being that the size increases is completely due to shielding. More energy levels, more space occupied. Notice on this table, which talks about not just the size of the cation, but in this one, the outer part is the atom. So this 152 is the atom number, and then this 0.68 is the ion number. You will notice that the outer energy level is gone, and so you end up with lithium, sodium, potassium, and rubidium all being larger than, but they're all smaller than the atom they came from. Another trend we want to look at is what happens as we go across. Remember, that's called the period trend. The period trend, if you take a look at this, it's very similar for all of them. These have lost one electron. As we pointed out, it's going to be a 1 plus charge. The 2A group has lost 2 electrons, and that makes it a 2 plus. And the third group, sometimes called the boron group, has lost 3 electrons and become 3 plus. You will notice this time that the size is going across looks quite different. You'll notice the 1 plus of potassium is larger than the 2 plus of calcium and the 3 plus of gallium. And what's occurring there is literally more electrons are lost. So there's an unequal balance of protons to electrons, and it pulls in more. Let's take an example. Let's do potassium. Potassium has 19 protons. That never changes. Calcium has 20 protons. That never changes. We skip all the way over to gallium, and we notice that gallium has 31 protons, and that's because it transition metals fit in here. In the case here, this ends up with 8 electrons. This ends up with 18 electrons, and this ends up with 18 electrons. What's happening is this protons are pulling in more. So 19 protons pulling 18 electrons makes it get smaller. But if we have 20 protons pulling on 18 electrons, it gets even smaller. And finally, in this comparison, 31 protons pulling on, and it wouldn't be 18, it would be, 20, let me fix that. That would not be 18, that would be 20, fix that, 28 electrons. It's going to pull in the greatest. So it's going to be what we call the smallest. If that confuses you, I would suggest that you just look at this right here and realize that as more electrons are lost, potassium, calcium, gallium, it's just going to get smaller and smaller and smaller. And that is because the nuclear charge is pulling in. When we switch to the other side of the periodic table, we're now looking at what are called anions. Anions are kind of the opposite. So we have metals, which are opposite of nonmetals, and metals tend to lose electrons. So when we think of nonmetals, we're going to talk about gaining one or more electrons. Anytime people think gain, they get messed up. So you have to think, I'm gaining negatives. If I gain negatives and I used to be at 0, I now have more electrons than I had before. So we could take an example of something like oxygen. Oxygen had 8 protons and 8 electrons. Oxygen wants to gain some electrons. To be honest with you, oxygen, we're going to find out, gains 2 electrons. We're going to end up with 8 protons and 10 electrons. These extra electrons are what makes oxygen a negatively charged anion, or just a negatively charged ion. Most of these nonmetals that are gaining electrons are trying to be like a noble gas. Remember, right here, these are the halogens. Next to it are the noble gases. These guys are stable. Everything wants to be like them. So right here, these tend to have 7 valence electrons. Not 10. They do have 7 valence electrons. Underneath oxygen, you have 6 valence electrons. 6 valence electrons. Here we have 5 valence electrons. And then things like carbon have 4 valence electrons. We're mostly going to focus from this over for our non-metals. The non-metals, because they have 5, but they want to get to 8, they want to get to the octet, they want to be stable, they're all going to gain. In the case of the halogens, they're going to gain 1 electron. In the case of oxygen and things underneath it in its group, they're going to gain 2 electrons. In the case of nitrogen, they're going to gain 3 electrons. You can kind of see here that if you have 5 and you add 3, you get to the magical octet 8. That's what's happening here. The nuclear charge is pulling for these electrons. Every time that electron is gained, the anion gets larger because that ratio is not correct. Remember, fluorine, right here in this picture, used to have 9 protons and an equal number of electrons. This fluoride still has 9 protons, but now has 10 electrons. These electrons take up more space, and therefore the size increases. Remember, electrons are moving and they're repelling each other, and so if you put more electrons into a space, they're going to have to push out and take up more space. This is a nice visual where it shows you that the nitrogen, which gained 3, is really quite a bit bigger. The oxygen, which gained 2, is quite a bit larger. And the fluoride, which has gained 1, is quite a bit larger. The trend for anions, for the nonmetals when they start gaining electrons, is that they go from biggest to bigger. every anion is going to be larger. Anything that gains electrons is going to have to take up more space. Remember, you're welcome to pause and look at any of these images and write down questions if you have questions, or just re-listen. So, what we also need to remember, which we already went over it a little bit, is that noble gases are what we call inert gases, and they're unreactive. Therefore, they do not gain. They do not lose. They kind of sit there and they do nothing. And so those will never be called cations or anions. They will be neutral. We've already looked at the trend across, and so now we're going to look at the trend down for the group. It's really better if we focus on this area right here. And we realize every time we get to a halogen right here, it's going to gain an electron. We already know it's going to get bigger. The thing we want to focus on is what happens to the element below it. So, below fluorine is chlorine. It got bigger. Below that is bromine. It got bigger. Below that is iodine. It got bigger. And so we notice that anytime we're going from top to bottom, we always have one more energy level. So it's always going to take up more space or have a larger volume. And that's due to shielding. So anions are larger because they've gained electrons. I kind of already detailed this, but this image again helps us look at the inner part. It's the neutral. The outer part is where the electrons now spin because there are more of them repelling. So, any atom that has gained or lost electrons is going to change in size. Electrons lost, smaller, cation. Electrons gained, larger, anion. Okay, I think because I need to start teaching another class, I'm going to stop this video and I will make the next topic, which is electronegativity and very important. I will put it on the next video. Thank you. Happy watching videos, chemistry videos. So cool.